There are differential equations that cannot be solved algebraically. In the previous chapter, we have seen how we can use Taylor series to come up with a polynomial and find the solution using good approximation. In this chapter, we are going to look at a different method to find the solution for a differential equation, at least finding a good solution to it, a good approximation. And we are going to use something called the Euler's method. Euler's method uses linear approximation to do it. Let me bring this back. Euler's approximation uses a linear approximation to find a good solution to it. So here, let's take a look at the concept. So what we are going to do is to consider a graph that will give us something that involves a differential, a dy dx. So in this case, we are going to assume that there is a point. So here is my point. This is the first point that we are going to consider. And there is also any value on this curve based on whatever x value you want to choose. So technically, at this point, at this particular point, xi, yi, any random point, you can actually calculate the slope at this point on the curve using the slope formula. Now, using this concept, I can now rearrange the expressions here to come up with something that looks like y equals mx plus b. Or technically, since we are now working with the point slope form, after you rearrange the term, you have an equation that looks like this. Now, if we are to consider this as the change of the x value, or here we call it the step length for the linear approximation, we can then make use of the point that we already know and use this point to approximate the value at this point. Now, seeing how the curve that goes from one point to another, the distance between these 2 points are relatively small. If you have your step length approach to 0, we will eventually come up with the actual value on this curve. So what happened is, if I want to come up with the actual value at this point, here we want to find this point, I can now increase the step length for this approximation. Using this point, I can choose a point that is very close to it and try to approximate the value at this point and use it to estimate the next one, and eventually you are going to come up with a very good estimate for this point using what we've started with. So as this approximation continue to, as you repeat this approximation, eventually we will come up with the point we want to calculate. So we are going to look at example number 1 to see how this can be done using the Euler's method.